In this video, we'll take a look at how to calculate the correlation coefficient in SPSS. Now, when we talk about calculating correlation, what we mean here is Pearson correlation. While there are other correlation coefficients, by far Pearson correlation is the most common correlation coefficient that's used, and it's the one that's included in introductory statistics texts. Sometimes there are other correlation coefficients as well, such as Spearman's rho, but Pearson's is the one that's focused on in nearly every text out there. The Pearson correlation measures the degree of the linear relationship between two variables. When we say linear, what we mean is that the relationship can be well characterized by a straight line. So a straight line does a good job at representing the relationship. And towards the end of this video, after we run the correlation, we'll create a couple of scatter plots to give you a better idea of what we mean when we say well characterized by a straight line. A correlation ranges from -1.0 to +1.0. And Pearson correlation is given by the letter R. And as an example, you might see something reported like R equals 0.55. Notice that this value of 0.55 ranges from -1 to +1. It's in that range. You should never see a correlation of 1.2, for example, above this value, and you should never see a correlation of -1.8, for example. Those both would indicate mistakes. So if you ever calculate and get an answer that's outside of this range, or you ever see someone report an answer outside of this range, something's wrong, so you should take a second look at your values. There are three types of relationships I'd like to talk about with Pearson correlation. And in this description, we have two variables. The first variable is x, and the second variable is y. So our first type of relationship is a positive relationship. And for a positive relationship, or a positive correlation, that's saying the same thing, higher scores on x are associated with higher scores on y. And what this means is there's a tendency for if an individual has a high score on x, they're also going to tend to have a high score on y. It's not necessarily perfect, in most cases it won't be, but if you know someone's score on x, it gives you a good idea of where they are on y. High on x, high on y. For positive, it's also true that if you have a lower score on x, you would tend to have a lower score on y. The second type of relationship is a negative relationship or negative correlation. Now here we see the opposite pattern. So here, higher scores on x are associated with lower scores on y. And vice versa. Lower scores on x are associated with higher scores on y. So this is an opposite pattern. Higher on x goes with lower on y. Lower on x goes with higher on y. Finally, our last type of relationship is no relationship. And that means there's no predictable relationship between x and y. And another way to think about it is, where here we had higher on x, we had higher on y for positive, and for negative we had higher on x was lower on y. Well, for no relationship we have, if you have a low x, you're going to have some low y's, some medium y's, and some high y's. If you have a high x, you're going to once again have some low y's, medium y's, and high y's. There's no relationship, no predictable relationship between x and y, for a correlation that exhibits no relationship at all between the two variables. Okay, with the background of correlation laid out, let's go ahead and take a look at our example. In this example, we have the following two variables, hours of media or hours media and college GPA. And what we did here in this hypothetical example is we recorded the number of hours of media during a given week that individuals engaged in, and media could be TV, movies, internet, and so on. So we recorded the number of hours of media that people engaged in a given week, and then we also obtained their college GPA. And we want to see if there's a relationship between these two variables, as measured by Pearson's R, our correlation. And if you think about it, if somebody watches a lot of media, so they're spending, let's say, an inordinate amount of time watching media, whatever form it may take, that's not going to leave them probably sufficient time to attend to their studies. And in that case, if we had a lot of hours of media watched, that probably would suggest that the GPA may be lower. Now, this may or may not be the case. We'll see what happens in this example. But if that was true, high hours media, low GPA, do you recall what kind of correlation coefficient that would be? Well, if we use the generic variables x and y here, high on x, low on y, so it's an opposite pattern, high on one, low on the other, that, you may recall, is a negative correlation. So it makes sense, at least theoretically speaking, that there could be a negative correlation here. But let's go ahead and run the analysis and see what we find. To run the correlation, we go to Analyze, and then Correlate, and then Bivariate.